Hello. Today we're going to begin to take a look at inverse sine and cosine functions. Let's go. So the first thing to know is how it's written. So this right here, this -1, this is indicating inverse. So this is the inverse cosine or the inverse sine, and they're also sometimes written this way as the Arccos or the Arcsin. And what inverse means is the angle whose, okay, so the inverse cosine x is the angle whose cosine is x. And the inverse sine is the angle whose sine is x. Okay, so what in the world does that mean? So let's say the question I've been given is the inverse cosine of -√3/2. And so again, that question is asking, what is the angle whose cosine is -√3/2, right? That inverse asks the question, what is the angle whose? Okay, so I'm going to draw a triangle. Now I know that cosine is adjacent over hypotenuse. So adjacent, that means my x, -√3. And then hypotenuse, that's 2. And then I might recognize at this point that this is a blank √3, 2 triangle. That's a 1 right there. All right, now cosine is also negative in my third quadrant. The inverse of cosine exists when x is greater than 0 but less than pi. So cosine inverse only exists in the first 2 quadrants. So I don't need to worry about a third quadrant here. So now if I want to know what is the angle whose cosine is -√3/2, well, I can take a look at my picture here. So I can see that this reference angle here, this is opposite the 1. This is a reference angle of 30 degrees. And so my full angle would be that one right there, or 180 degrees minus 30 degrees, or 150 degrees. And if this is happening in radians, then I would think of it this way. Pi, that's my 180, minus pi over 6 equals 5 pi over 6. So what is the angle whose cosine is -√3/2? That would be 5 pi over 6, or 150. Okay, let's take a look at another. Okay, so we want the inverse sine of -1/√2. Can you turn that into a sentence for me, a question? That's right. What is the angle whose sine is -1/√2? Okay, so we're going to do a picture again. Now, the first thing I'm going to do is I'm going to rationalize this denominator. So I'm going to multiply top and bottom by √2 to get -√2/2. So again, I know my sine is opposite over hypotenuse. Opposite is negative. That means I'm going to be going down. And then my hypotenuse is 2. And then I would use my Pythagorean theorem to remember that this is also a √2. Now, same question, sine. Well, that's negative in both the third and the fourth quadrant. So here's what to know about inverse sine. Inverse sine exists between -pi/2 and pi/2, right? So here's -pi/2, here's pi/2. So its only options are the first and fourth quadrants, which is why I don't have to consider my third quadrant. Okay, so what angle is this? Well, unit circle tells me my √2, √2, 2. This is a 45-degree angle as my reference angle, which means the angle I'm looking for, so my reference angle is 45 or pi over 4, but in order to designate it as being in this fourth quadrant and being between negative pi over 2 to pi over 2, I'm going to write this as negative pi over 4. Now we know these angles can be written lots of ways. We can describe it as moving in the negative direction. We could also describe it as moving in the positive direction. But because this designation, where an answer to an inverse question for sine has to be between negative pi over 2 and pi over 2, my answer has to be written not as the positive version of this, but as the negative version. So it could be pi over 4, or it could be negative 45, depending on whether your teacher wants it in degrees or radians. Okay, let's take a look at a more complicated version. The inverse sine of cosine of pi over 3. Okay, so forget about the outside for a second. Let's just look at the inside. The cosine of pi over 3. Pi over 3, that's 60 degrees. So if I'm in my unit circle, that means my hypotenuse is 1. Opposite 60 degrees, or pi over 3, I have root 3 over 2. And then opposite the final angle, I have 1/2. By the way, if these don't just roll off your tongue, go take a look at my videos on the unit circle and on 30, 60, 90 triangles. You want to get so familiar with this that you don't even have to think about this part of things. Okay, so now cosine. Cosine is adjacent over hypotenuse. Adjacent, that's 1/2. Hypotenuse, that's 1. The cosine of pi over 3 is 1/2. And now we're back to the problem we were in before, the inverse sine of 1/2. Okay, sine, do you remember its designation? That's right, it can be in the first and in the fourth quadrant. Where sine positive? Only in the first. So we know we're going to place this guy in the first. Okay, so this is asking the question, what? What is the angle whose sine is 1/2? Okay, we make our triangle. Sine, that's opposite over hypotenuse. 1/2 and 1, and that leaves us with root 3 over 2 here. That's right. And so then if we are looking for what angle here has a 1/2 opposite it, that is a pi over 6. And so the inverse sine of 1/2 equals pi over 6. Okay, so that is your beginning look at inverse sines and cosines. Here's your limitation on what x can be for the inverse sine. Here's your limitation on what x can be for inverse cosine. And inverse is asking the question, what is the angle whose sine or cosine is x? All right, leave any questions you have in the comments. Stay tuned for more videos. This subject goes deep, so there'll be video 2 and 3 coming out soon. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.